right, let's talk about the law of sines, which we use to solve oblique triangles. Triangles are oblique if they are not a right triangle. So you need to know how to label an oblique triangle or any triangle. You know you have three sides and three angles. Our angles are going to be labeled using uppercase, capital letters. And then our sides will be labeled using lowercase letters, and they correspond to the side. So side A is across from angle A, side B is across from angle B, side C is across from angle C. All right, so where did this law of sines come from? It actually comes from what we did in an earlier section when we looked at the area of a triangle. Remember that if we were looking for the area of a triangle and we were given two sides, so C and B, and the angle was included. So here, the angle A is included between side B and C. We knew that the area was 1/2 times the sine of that angle times the sides. All right, and I could do that with angle C and angle B. Look at angle B. So angle B is between A and C, so that would equal 1/2 times the sine of B times A times C. Or angle C, likewise, it would be the sine of C times A and B. Angle C is between side A and B, so this would be 1/2 times the sine of C times A times B. Now the law of sines just comes from me doing a little algebra here and cleaning this up. So I'm going to multiply by 2 over A times B times C, right? And that's going to get rid of those 1/2s, and it's going to get rid of 2 of the sides. So it's going to leave me with the sine of A. My B and C are going to cancel out and leave me with A equals the sine of B over B equals the sine of C over C. All right, so this is my law of sines. All right, so let's look at examples and make sure you go back to Canvas to get more of an introduction if you're not in Canvas right now. All right, so in this first example, they give me that angle A is 37.5 degrees. They give me that angle B is 28.1 degrees. They give me that side A is 17. And they ask me to find side C. Okay, so first thing you want to do, draw and label your triangle. So I'm going to draw a triangle, and it doesn't have to be drawn to scale. You can just draw any oblique triangle and then make sure that makes sense at the end. All right, so we've got A, B, and C. They told me that A is 37.5 degrees. They told me that angle B was 28.1 degrees. They told me that sides A was 17, which is across from angle A. And I am looking for my unknown, which in this case is side C, across from angle C. All right, now if I'm going to set up a proportion using the law of sines, I can only have one unknown. I'm only going to be using 2 of these ratios at a time. But if you'll notice here, this is my unknown, so I'm going to have to use C. I have to know what angle C is. Well, they've given me 2 angles, which is actually something I need to bring out probably before I even start working this problem. Why are we using the law of sines? We're using the law of sines because they gave me 2 angles and a side. So I was given a side and 2 angles. All right, so I'm using the law of sines here. And continuing on, I need to set up a proportion. So I'm going to need angle C in order to do that. Well, if I'm given 2 angles, I know how to find that third angle, because to find that third angle, I just subtract the other 2 angles from 180, because we know the total, the sum of the angles in a triangle is 180. So we've got 180 minus 37.5 minus 28.1, which means angle C is 114.4 degrees. All right, so I'm going to use that, set up my proportion. So my ratio for sine of C, so I've got sine of 114.4 over my unknown, which is x in this case, or C if you wanted to keep it labeled appropriately. And that is going to equal another proportion. Well, the only other proportion I've got, the only other ratio I've got is angle A inside A. So I have to use that. So it's going to equal the sine of 37.5 degrees divided by 17. Now, once you've got this set up, all we're going to do here is cross multiply and isolate x, right? We're solving for x, which is my side C. So when I multiply, I get 17 times the sine of 114.4 equals x times the sine of 37.5. So to isolate x here, I'm going to divide both sides by the sine of 37.5 degrees. And when I do that, I'm just going to punch that in my calculator. It's going to give me an approximation, and plugging it in your calculator, you get 25.4. So this side C is 25.4. Now what you need to do is check and make sure that makes sense. Remember that our biggest side is going to be across from our biggest angle. So my biggest angle in this case was C, and 25.4 is bigger than 17, so this makes sense. So we're going to go with that. All right, let's do another example like that. All right, so we're given that A is 120 degrees. We're given that side A is 45. We're given that side C is 36. And we are told to find angle C. All right, so let's draw a picture. That didn't work out too well. All right, so we've got A, B, and C. All right, they give me that A is 120 degrees. They give me that side A is 45. All right, they give me that side C, which is across from C, is 36. And I am supposed to find angle C, or theta. I'm going to label it theta. All right, so let's talk about what we were given. We were given two sides, and we were given an angle, and that angle is not included. All right, if the angle is not included, I'm using the law of sines. I'm going to use the law of sines in order to solve for theta, okay? So my proportion that I'm setting up, I've got a ratio of sine of A, 120, over side A, over 45, has to equal the sine of C, which is what I'm looking for, over 36. All right, when I cross multiply here, I get 36 times the sine of 120 degrees equals 45 times the sine of C. I'm isolating that. That's my unknown. That's what I'm looking for. So I'm going to divide both sides by 45. And so that I know that sine of C equals 36 times the sine of 120 degrees over 45. Now what? Well, if I'm looking for an angle, hopefully you've remembered, if you're looking for an angle, you have to use the inverse. You're looking for an angle, you're using the inverse function. In other words, I'm looking for the inverse of all this. That's going to give me my angle. I'm going to use my calculator. I'm going to punch it in. And it's going to give me my approximation of 43.9 degrees. If I go back to my triangle and think, does that make sense? Well, my biggest angle is 120, and that's 45. I know this can't possibly be an angle that's bigger than 120, so 43.9 for this does make sense.